Section 2.1, Properties of Numbers. Our first property we're going to look at is commutative property of addition and multiplication. Commutative property means to change order. I use the CO in commutative to remind me of that operation, change order. It looks like this. 8 plus 3 can equal 3 plus 8. 8 plus 3 is 11, 3 plus 8 is 11. So you can see in addition, it does not matter what order it comes in, it will always turn out to be the same sum. Same with multiplication. 4 times 5 equals 5 times 4. 20 equals 20. It can be done with the dot, which is the representation for multiplication, or with parentheses. It doesn't matter. This is our arithmetic version. Our algebraic version looks like this. A plus B equals B plus A. In other words, it doesn't matter what number, real number, is in for A and B. Commutative property works for multiplication and addition for any real number. Our next operation is the associative property. The associative property is for addition and multiplication, and that is to regroup. Notice when I do the associative property, the order does not change. That is very important, because if the order changes, it's commutative property. Regrouping is purely for the associative property. Here's the arithmetic version. I have 5 plus 7 plus 2 on the left side, 5 plus 7 plus 2 on the right side of the equal sign. Notice here, the grouping is 5 plus 7. 5 plus 7 is 12. 12 plus 2 is 14. On the right side, I have the same order, again, 5 plus 7 plus 2, but their group is 7 plus 2, which means I would do that first. 7 plus 2 is 9. 5 plus 9 is still 14. Same for multiplication. 4 times 3 times 5. On the left, 4 times 3 times 5 on the right. This would give me 12 times 5, which is 60, and this would give me 3 times 15, but that times 4 would give me 60 also. Notice the order is the same on the left and right. It's the grouping that changed for the associative property. The algebraic format of that is the same. A plus B plus C on the left, A plus B plus C on the right. It's the grouping that changes. And the same for multiplication. A times B times C, and here it's B times C first, then A. But notice A, B, C, A, B, C. It's the grouping that changes. And for algebra, it doesn't matter for any real number for addition or for multiplication. The associative property holds. In other words, the left side always equals the right side, no matter if I regroup. Our next is the identity property of addition and multiplication. This kind of means no matter what I do to one side, it doesn't change the value. It still remains itself. In other words, for the arithmetic version, if I have 15, 15 plus what value will still get me 15? That would be 0. So 15 plus 0 is 15. For multiplication, I can't use 0 because 0 times anything is 0, so it changes the outcome. I want 7 times what number gets me back to 7, and that would be times 1. So for addition, I would be adding 0 for the identity property. For multiplication, I would be multiplying by 1. And in each case, that would get me back to where I started. In algebra, that's any real number plus 0 gives me that real number. And in algebra, for multiplication, any real number times 1 gets me that real number back. In this example, I want to use the associative property to write two different expressions that you could use to find each sum. I want to add 12, 17, and 5. So I'm going to put down 12 plus 17 plus 5. And notice I left some spaces. And what I'm going to do here is I am going to use the associative property. So here I'm going to group the last two first. And when I find the sum, I bring down my 12. Because of order of operations, I do what's inside my parentheses first. 17 plus 5 is 22. And 12 plus 22, I get 34. Now, since I'm going to use the associative property, I need to have this value, which is 34, be the same over here. It's going to look very similar. I'm going to keep the same order, which is 12, 17, and 5. Now recall, it asked me to use the associative property. And that means my order does not change, but my grouping does. So now I'm going to do the first group here, which is 12 plus 17, which is going to give me 29 plus 5, and 29 plus 5 is 34. So the associative property holds for addition as we stated on a previous slide. Name each property shown. Number 1, x times y equals y times x. Notice the order changed. CO, change order. That means commutative property. Number 2, 3 plus 7 plus 4. 7 plus 4 plus 3. Notice it looks like I have parentheses, so your first inclination is to go associative property because it has parentheses. But notice the order changes. 3, 7, 4. 7, 4, 3. So it changed order. So again, this is the commutative property. Number 3, 8 times 1 equals 1 times 8. Again, this is kind of a trick. It shows me 8 times 1, so I'm thinking this is the identity property. 8 times 1 would equal 8, would be the identity property, but this says 8 times 1 equals 1 times 8. Again, it changed order. This is the commutative property. So watch for those tricks. Number 4, 3 plus 7 plus 4, 3 plus 7 plus 4. So notice the order is the same, 3, 7, 4 on both sides. But what changed were the groups. They moved the parentheses and grouped 7 and 4 here and 3 and 7 here. So this is the associative property. Again, name each property shown. Here I have a negative 5 times 3, 3 times a negative 5. And notice all they did is change the order. I know the 3 is in parentheses here and not here, but this is changing order, so this is commutative. Zero plus 8 equals 8. That is the identity property. Number 7, 9 times 1 equals 9. Identity. Number 8, 9 times 6 plus 1. 9 times 1 plus 6. Again, the trick here is you're looking at the parentheses and thinking associative. But notice the order changed. 9, 6, 1, 9, 1, 6. So this is the commutative property, change order. Here it says, use mental math to simplify each expression. In that situation, we really don't want to write this down and change anything. We want to use our head. But I'm going to show you how I would write this down just so you can see what I'm doing to make this easier to add or multiply. And here's my situation. Number 1, 10 plus 27 plus 70. This is going to be a lot easier to add the 10 and 70 together first. In other words, I would do this, 27 plus 10 plus 70, which is the commutative property, and then I would regroup. And I know I'm allowed to do that because that property holds or is true for addition. Now it's easier to do this, 27 plus 80. And I know 20 plus 80 is 100, and then 7 is 107. So in my head, I wouldn't write any of this down, but I would know to go 10 plus 70 is 80, plus 27 is 107. Let's take a look at this one to see if we can do this one in our head. I see the 0.3 and the 0.7, which I know will become 1. So I'm going to add these two first. 1.3, 2.7, 1 plus 2 is 3, but 0.3 and 0.7 gives me 1, so I know that's 4, plus 2.5, which is 6.5. So these properties give us an advantage that we can know that we can manipulate the problem in our head to solve it without using any other instruments, just using our mental ability. Here we want to evaluate each expression. I am given a negative k times t times a negative r for k equal to 5, t equal to 20, and r equal to 7. So what we need to do is substitute. So I'm going to write this problem down on my paper. So if I was at home and I see this in the book, I would write a negative k t times a negative r. Then I would substitute. So I need to see this. Then I substitute. For k, I bring down my negative. K is 5. I'm going to put that in parentheses. Even though there aren't, I'm going to put it in because I know I'm multiplying. Bring down these set of parentheses. T is 20. And then close the parentheses. Bring down my parentheses. Bring down my negative. R is 7. Then close it. Now, I'm going to multiply. And here it is easier to multiply these two together. A negative 5 times 20 is going to give me a negative 100. And I'm going to show this. You don't have to because this is pretty simple here. But if you need to, please do so. Bring down the negative 7. That's going to give me a positive 700. Same directions. Evaluate each expression. I have a number 2, negative v times w times p. And they give me what to substitute. I'm going to write this again if I'm at home. I write it from the book. So I need to show this step. Then I substitute. I bring down my negative. My v is 3. W is 9 times p, which is 30. And now I'm going to take 9 times 30. I'm going to bring down my negative 3. 9 times 30 is going to give me 270. And then a negative times a positive is a negative. And 3 times 270 is going to give me 810. Maybe a simpler way to do this would be to reorder this and do 9 times 3 times 30. But of course, that's a negative 3, so that would be a negative 3. And then group it this way. 9 times a negative 90. And now you can see 9 times 9 is my 81. Of course, positive times a negative is a negative. And then I just bring the 0 down. So this, again, is where our properties would help a lot better